Okay, moving on to problem 91 from chapter 2. A rock is dropped from a 100-meter high cliff. How long does it take to fall the first 50 meters and the second 50 meters? So you have a rock that's positioned at initial height, which is 100 meters per second, and then there's an intermediate height that's called a YF, is at 50 meters. And then the final height, another final height, which is at the 0 meters, depending. So this will be the first 50 meters, and this will be the second 50 meters. You want to find the time. So we can call this T1. We can call that T2. So you'll also find how much time does it take from this point to that point, and then from that point to that point. Okay, and so what is the initial velocity? Because it said that it is dropped, so you can assume you can see that the initial velocity is basically let's see, you have that. So what we have here, what do we have here? We have initial height and the final height and initial velocity. So let me just write it here. So initial velocity at this point, because it's dropped, so it undergoes a free fall. So it is 0 meters per second. So you're going to find the T1, and the acceleration that experience is negative g, so negative 9.8 meters per second squared. Okay, so you have your final height during the first 50 meters. You have the final height that's equal to initial height plus initial velocity times time plus 1/2 at squared. So we're going to plug in the numbers that we have here. So the final height during the first 50 meters will be 50, and the initial height is at 100. Initial velocity is 0, and then plus 1/2, the acceleration is negative 9.8, and your t here is the one we'll also find. So we're going to use T1, okay, and T1 squared. So after you plug in the numbers, you should find that your T1 is equal to 3.19 seconds. Okay, so that answers the question. The first question, that's 3.19 seconds. And then you also find how much time from this point to that point. Now, we could have used the same equations here if we know the velocity. Because remember, now that's so we really should take this. So this will be your initial height. This will be your final height. So let me just, we can actually use that. So now it becomes initial height. So your initial height is at 50. Your final height is at 0. You don't know the time. You have the same acceleration, but you don't know your initial velocity now. So it's very it will be a little bit, you can't just use this equation because you're missing the information about the initial velocity. Unless you calculate the initial velocity at that point. How do we do that? We know that the velocity at this point is 0, so we can easily calculate the velocity right here. So your final, so you can actually, so again, if you just take the first 50 meters, this will be your initial point. This will be your final point. And if you're thinking about the second 50 meters, then this will become your initial point, and that will be your final point, okay? So we're going to use this to calculate the velocity at that point. So we have, so the velocity here is basically is, if you're taking this set, so that will be your VF. So your VF here is equal to VI plus AT1, okay? So your VF here, we don't know, and your VI is 0, minus 9.8, and then times your T1, which is 3.919. So your VF here would be negative, let me see, do I have that value? Negative 31.26 meters per second, which means that after 3.19 seconds, the velocity at this point, is negative 31.26 meters per second, okay? So now you have this velocity. So now you're going to treat this as your initial velocity, and then this is your final height. So you can actually use this equation to calculate how the time t2. So I'm going to set the equation like this. So you have your YF. You still have your let me just write here. So you have your YF. That's equal to YI plus initial height initial velocity times t2 plus 1/2 at2 squared. Okay, so the final height, if you're looking from this point to that point, your final height is 0, and your initial height is at 50, and the initial velocity, we just calculate that to be, at this point, is negative 31.26 plus negative 31.26, and then times t2, and then plus 1/2 negative 9.8, and then times t2 squared. So you can see that this equation again gives you a quadratic equation, and you can calculate your t2, and your t2 then becomes 1.33 seconds. Okay. Or additionally, let's see, do we want to do another way? Let's see. Yeah, so we can just use that, and they can calculate that. So your T2 here is 1.33. Or alternatively, what you can do is that if you treat this as initial, if you treat this as a final, and then if you stay with the initial velocity to be 0 because you're using that one, and then just find out the total time from this point to that point. If you find out total time and then subtract the time that you already calculated during the first 15 meters, then that will give you T2 as well. So just do that. So if you're using this as initial, use that as your final. So I'm going to draw that. So you have your initial, your final. Your final is 0, and your initial is 100. And then initial height is 0 times the t, and then minus 1/2 9.8. So I'm just going to negative 9.8, and then times t2. So you can see that this is a quadratic equation, but it's not quadratic equation because the initial velocity actually is 0. So it's it is actually easier to calculate your T2 without going through the quadratic equations. So your T here is 4.52 seconds. And then, remember, because you're using from this point to that point, so that's your total T. So use that. So your T2 is your 4.52 minus the first time segment, which is 3.19. And that will give you this value. Okay, so there are many ways to solve the same, to get the same values. Just depends on how you, which point I choose as initial and which point you choose as a final. And then you just have to make sure that you have the information required when you use the equations. Okay, so that's your 91, problem 91. And the last problems that I want to do is problem 99. And I'm going to erase this. Problem 99. A ball is thrown vertically downward from the top of a 36.6 meter tall building. The ball passes the top of the window that is 12.2 meters above the ground 2 seconds after being thrown. What is the speed of the ball as it passes the top of the window? Okay, so whenever you do problems, you want to draw a diagram to help you better visualize what's going on and associate the number with the symbols. So we have a building, and we have the building, and we have the top roof, and we have the window. Okay, and it says that a ball is thrown vertically. So let's say the ball is initially right here, and it is thrown vertically downward. So remember, it's downward, which means that it has a negative value because it's downward. And it's located at 36.6 meters. Okay, and it said that there's a window. When the ball passes in the window is 12.2 meters above the ground, and the time it takes is 2 seconds. And because it is going downward, which means that it experienced the free fall acceleration, which is negative 9.8 meter per second squared. So we're going to take this. So this is your final height, that is your 0, and this is your initial height, which is where the ball is located, which is 36.6 meters. Okay, and so you'll also find what is that initial velocity. Now let's look at what information we have, from this point to that point. We have the initial height. We have, like intermediate height, that we can take this as your final height, just comparing these 2 points. So we can take that as your final height. We know the time that it takes from the ball moving from this point to that point, okay? And we don't know the initial velocity, but you'll also find the initial velocity. So you can quickly use the equations of motion. It becomes very straightforward. So you just have the final position is equal to initial position plus initial velocity times time plus 1/2 AT squared. So you can see that you have all this, the same equation. Final height is at 12.2. Initial height is 36.6. We don't know about the initial velocity. We know about time, and then plus 1/2 negative 9.8, and then times 2 squared, the time squared. So you can see that from this equation, there's only one unknown, which is initial velocity. So initial velocity can be quickly calculated, and you will get, by the way, since we know that this, we want to calculate the numerical value, you can actually use this, we can just use the negative. If you just calculate the magnitude, which is a positive value. So this has to be negative, okay? So after you do that, then your V is equal to 2.4 meter per second. So in other words, your V, if we really should just write down to be negative 2.4 meter per second, okay? All right, now, what about the final velocity? What is the speed when it passes at this point? So what is that VF? So you have VF, that's equal to V naught plus AT. So VF is just initial velocity, which negative 2.4 because it's going downwards. So it's negative 2.4 and then minus 9.8 and then times 2. So your velocity at that point is negative 22 meter per second. Okay. Now, if you want to keep this, if you want to keep this as a positive, that's fine. So if you keep this the sign as positive, then after you do the calculation, you should get your V naught that's actually equal to negative 2.4, which is actually consistent with the pictures as well. So you just when you do this, you calculate the numerical value. When here, it was like indicating the direction which is downward, so you have to put a negative sign in front of it. Okay. Alrighty.